Hello students, welcome to the video class for the subject Basic Electrical Engineering, and this subject is for first semester diploma engineering students. So in the previous class we started from the fundamental part. So in this fundamental portion, we covered the in the previous section class we already covered the concept of current flow, concept of source and law. So today we will discuss about Ohm's law and concept of resistance, then relation of V, I and R in series circuit, relation of V, I and R in parallel circuit. Okay, so let's move to the main part. So the electrical load is an application consuming electrical power. So electrical load, mainly in the simple language, you already heard about the appliances, electrical appliances whichever we are using in our home, and those appliances are consuming electrical power. So those are all are the electrical load, and it is represented by resistance, inductance, capacitance, back EMF, or combination of all the circuit elements. So here some examples are given. This is a resistance, resistive load. This is inductance, it is inductive load. This is capacitance. So capacitive loads are like your so the resistive load examples are like the incandescent lamp, electrical heaters. These are all the resistive load which produces mainly heat. And then inductive load examples are like your motor, transformer, chokes. Chokes are mainly used, you have seen in chokes are used in the tube light connection. And then your capacitive loads are like your radio circuit, synchronous motor, capacitor bank, TB picture tube, buried cables, motor starter circuit, etc. So these are all the examples of your loads which are used in your home. And this is your combination of this is the combination of RL load, this is the combination of RC load, this is the combination of RLC series load, and this is the representation of capacitor, this is the representation of the inductor, this is the representation of the resistor, and its unit is, this is the representation of its unit called as ohm, and its unit is also ohm, but in the inductor unit is actually, inductance unit is Henry, and the capacitance unit is actually Henry, it is represented as capital H, and capacitance unit is Farad, represented by capital F, and its unit resistance is Ohm. Okay, clear? Now let's begin the topic, Ohm's law and concept of resistance. So what is this Ohm's law? It states that at a constant temperature the current passing between the 2 points of a conductor is directly proportional to the potential difference existing between the 2 points, and mathematically it is expressed as I proportional to B. Okay, I is the current passing in between the 2 points of a conductor, and B is the potential difference exists between the 2 points of a conductor. So if I proportional to B, then it is represented by B is equal to I into R. Here R is the constant of proportionality. We can write B is equal to IR, or I is equal to B by R, and from this your R equation, R is equal to B by I. Okay, so electrical current in a conductor consists of movement of electrons. Already I told you current is the flow of electron. Okay, so when electron flow, through a material, they collide with other atomic particles and energy is lost in the form of heat. And due to this collision, whatever heat is generated, this is represented by your resistance term. So resistance is the property of a material by virtue of which it opposes the flow of electron or flow of current through it. So the opposition of flow of current is due to the above collision of electrons. Okay, so in general, in simple language, you can define resistance as resistance is a property of a material which opposes the flow of current. Okay, so in the other way we can define resistance as see here, resistance of a conductor. This is here your one conductor cross sectional view. So resistance of a conductor, resistance of a conductor depends on its length. This is your length and it is represented by L, capital L, and area of cross section represented by capital A, and specific resistance or resistivity which is represented by the rho symbol of the material. So resistance of the conductor depends on these parameters or these factors. Then the resistance is given by R is equal to rho L by A. So R is the directly proportional with the resistance, R is the directly proportional to the length of the conductor. Then R is inversely proportional to the area of the cross sectional area of the conductor, and this rho is the proportionality constant here, and it is named as or represented as specific resistance or resistivity. Okay, so in this diagram here the length is 1 meter and area of cross section is 1 meter square. Then R is equal to rho L by A. This is this is your formula for resistance. Okay, so the next part is the relation of B, I and R. So what is this B, I, R? We already discussed in the upper part. B is the potential difference. It is also called as voltage. Its unit is volt. I is the current. It is represented by capital I. Its unit is ampere, and R is the resistance, and it is its unit is ohm. Okay, so what is the relation of V, I and R in series circuit? So what is this series circuit? First we will discuss what is this series circuit. See, series circuit means what? See, conductors are said to be connected in series if they are connected end to end, one after another, so that one end of the first conductor and one end of the last conductor are free, and same current flows through all conductors, and potential difference across each one is different depending upon their resistances. Okay, see here, AB is one conductor, this is AB is one conductor, then BC is another conductor, then CD is another conductor. So one end of B is connected with the one end of C. Then here also one end or other end of the C is connected with one end of the D, and the first end of the A and the last end of the D are free. So this is the series connection. So same current flowing through this series connected circuit, that current is I, and potential difference across each conductor is different, that is V1, V2, V3, and in each conductor the resistance is R1, R2, R3, here represented like this. Okay, so here AB conductor has resistance R1, BC conductor has resistance R2, CD conductor has resistance R3. So let let the R, capital R, here R is the resistance of the combination, and V is the total potential difference across resistances, and I is the strength of current. So then V is equal to I into R. This we got from according to Ohm's law. V is equal to I into R, and V is the, here V is the sum of individual potential difference across R1, R2, R3. This is, see here, V is the sum of individual potential difference across R1, R2, R3. So we can write V is equal to V1 plus V2 plus V3. This is the equation of the total, or this is the equation of the sum of the individual potential differences. And V is equal to IR is written here according to Ohm's law. So I can write V1 means what? V1 means voltage. V1 means voltage potential difference or voltage drop across the conductor AB. So in conductor AB, resistance value is R1 and same current flowing through the all the conductor, that's why it is I into R1. And again V2 is I into R2 and V3 is I into R3, and V is equal to what? I into R. So this is equation 1, this is equation 2. So if we combine 1 and 2 equation, then we got I into R. In the place of V, we can write I into R, and in the right hand side it is IR1 plus IR2 plus IR3. See, so I cancel out each other, then we have R is equal to R1 plus R2 plus R3. So what you found at the, what is the conclusion here? It follows from the above that if the number of conductors are connected in series, then the combined resistance of the combination equals the sum of individual resistances. This is the combination, and this is the conclusion we get in the relation between Vi and R in the series circuit. So in series circuit, the equivalent resistance is the sum of individual resistances. Okay. So the next one is the relation of Vi and R in parallel circuit. So what is this parallel circuit? Let's first learn about this parallel circuit. Parallel circuit means conductors are said to be in parallel, connected in parallel, if all of them are connected across 2 points. All of them are connected across 2 points. See here, see, this is one conductor, this is one conductor, this is one conductor, and each conductor has resistance R1, R2, R3, and these 3 conductors are connected across 2 common points. So this is one common point and this is one common point. So let it named as, this is A point and this is B point. Okay. So in this figure, 3 conductors of resistances R1, R2, R3 are connected between the common point A and B. It will be observed that same potential difference exists between the ends of each conductor, but the amount of current passing through each is different depending upon their resistance. So voltage potential difference or voltage across each conductor is V. It is written here, and current flowing through each conductor is different according to their resistances. So here in the one conductor the current flowing is I1, in the second conductor it is I2, in the third conductor it is I3. So see, suppose the main circuit is divided into I1, I2, I3. In this circuit, suppose the main current, here the main current is I. So when if the main current is divided into I1, I2, I3 to the resistance R1, R2, R3 respectively, then assume that let capital R is the resistance of the combination between A and B. B is the potential difference, I is the strength of current. Then I is equal to V by R. It came from V is equal to I into R. It is from Ohm's law. So if B is equal to IR, then I is equal to V by R. Already I told you. And by KCL is Kirchhoff's current law. We go to this Kirchhoff's law part in the later part. We will discuss about this Kirchhoff's current law. Here you just know the in short that by KCL the main current entering this combination must come out as, okay, according to Kirchhoff's law means whatever current entering in a circuit is equal to whatever current outgoing from the circuit. Okay, so if here I amount of current is entered at this point, that means at this point the whatever current is leaving or whatever current is outgoing is equal to this value. So if here I current is entering, then here also I amount of current is outcoming. Okay, so from KCL we can write I is equal to what? Here see, here I is divided into three part, I1 plus I2 plus I3. Okay, so if I amount of current is entered here, then here what? I1 I2 current is outgoing, so we can write that I is equal to summation of these three, so I1 plus I2 plus I3. So see here, if when we apply KCL, then we got this expression, this equation, that is the I is equal to I1 plus I2 plus I3, and we already found that I is equal to what? I is equal to V by R, because V is equal to I into R. So if I is equal to V by R, so for I1 we can write V by R1, for I2 we can write V by R2, for I3 it is V by R3, and for I it is V by R. So in both left hand and right hand side V is common, so V is cancelled out, then the rest is the B. See, this I told you, V by R is equal to V by R1 plus V by R2 plus V by R3, and V cancelled, then 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So what conclusion you got from this expression? That it follows from the above that if a number of conductors are connected in parallel, then the reciprocal of combined resistance is equal to the sum of reciprocal of individual resistance. So this is the final conclusion of the relation between V, I and R in parallel circuit. So what is the conclusion here? That 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. That means reciprocal of the combined or equivalent resistance is equal to the sum of reciprocal of individual resistances. Okay, so you clearly understood whatever we studied in the today's class. So follow this video and make note by yourself. Okay, thank you.